Do not miss any of our cool videos. Subscribe to our channel for latest updates. Click on the bell icon now.
Hello and welcome guys. This is Moinak from KRSSG IIT Kharagpur, and today I'm going to demonstrate a very exciting application of machine learning for embedded applications. But wait, you need hardware for that, right? Obviously not. You can do that without any hardware, and that's what I'm going to show in this video. So stay tuned and watch till the end. So for implementing whatever I'm trying to say, uh, we'll have to use an online studio that's available that's called Edge Impulse. Yes, you must have heard about this, right? There's a very popular tool that is used to build ML applications for the edge. So how do we go about using this, and how do we uh, uh, actually implement a real life project without any specialized hardware like an Arduino or a Raspberry Pi? So I'll show you how. For this project, we are only going to need a smartphone. Yes, you heard that right. Just a smartphone that has some sensors like accelerometers, cameras, microphones, whatever. So for this application, we are just going to use the accelerometer of the uh, smartphone. So let's get started. The first thing you need to do is create a project on Edge Impulse. So before that, you'll have to create your account on Edge Impulse. So I believe you can handle that easily. So I'm not discussing that. Like something as basic as creating an account. After that's done, you will be greeted by this page that's called the dashboard. So on the dashboard, you can manage all your projects that you've created in the past. Like you can see what devices you have used to connect to, and how much data you have collected. Things like that help you like keep track of how you have created those projects and how what kind of data you've collected. So we don't need any of this right now. Let's just get started with a new project. So you can just go over to your profile and create a new project. So first you'll have to name this project. I'll name it demo 2 maybe. Sure. So alright. So we've created a project. Now we need to go about adding. So what do you need for actually building a machine learning model? Firstly, you need a training data set that will be used to uh, train the device that is going to draw inferences from whatever data you're sending. Like in my case, I'm just going to make a simple gesture recognizer model that will recognize whether I'm like this is my smartphone. So it will recognize whether I'm like uh, you, like I'm giving it a gesture as a zigzag or a circle or just an up and down motion. It's going to recognize that. So how are we going to do this? The first thing is that we need to make a training data set. The training data set will be used to create that model, to train the model so that it is able to recognize these movements later. So after we have done that, we will uh, we will again collect a test data set that will be used to test whatever if the model is functioning correctly or not. It will also help us judge whether the model we have created is actually performing according to expectations or not. So let's go ahead and collect some accelerometer data. It prompts us to connect a development board, but here I said that we are not going to use a development board, so let's not focus on that. So let's just cross this out and let's collect some data actually. So yeah, I clicked on let's collect some data, and now you can see these many options. Like it gives you various options, like you want to use your computer, your mobile phone, or just a supported development board. You can look into this, what kinds of boards are supported. You can also check out the videos of on this channel regarding the Arduino TinyML kit, so you can get hold of that also. So you can see that the Nano 33 BLE Sense is supported. It also supports popular platforms like Raspberry Pi 4 and NVIDIA Jetson Nano. However, we don't need to pay any heed to this now, because we are going to use our smartphones. So let's just get started with like using our smartphone. So what I'll go do is I'll just mirror this my smartphone screen. Yeah. So here I have my smartphone screen. You can see that. So we'll just to get started with collecting data, you have to scan a QR code that's available uh, on the Edge Impulse website so that it directs you to a page that helps you in collecting data. Alright, let's show the QR code. The next thing is you're going to do is you have to scan this code. So for this, as you can see on my smartphone, I've loaded up my browser, which is Google Chrome. Now, in many Chrome versions, the QR code scanner is not available. So what you can do is you can go to a website like webqr.com that helps you directly scan. All right. All right. So now you can see that we have finished scanning. Can show that on the phone. Yeah. So you've seen that after scanning, we are greeted with we are given a link to like for collecting data on the Edge Impulse website. So we can directly visit that link, and you can see it's connecting to Edge Impulse. All right. So yeah. So once the phone is collected, we can go ahead to the data acquisition tab. Acquisition tab will help us collect the data. So you can see many tabs over here. The first tab is the data collected tab, which will show whatever data you have collected until now. This tag is called labels. Right? What labels actually do is like suppose you want to suppose you want your model to recognize different types of gestures separately. So you want to load something like a zigzag motion and a circular motion or an up down motion. You can create separate labels for all these types of motions, and then you can directly upload that to your model so that the model can recognize all these different types of motions separately. So what I'll do is I'll just collect some data. Uh, Wait a second. All right. So I'm going to use my smartphone for collecting data, right? So you can see that the device is already connected, which is my phone. Now I'll create a gesture label. I'll call it up down. So what this up down gesture will do is that it will recognize up and down motion, like along the Z axis. It will recognize the motion of the smartphone. So I'll start sampling. All right. You can see that I'm moving my smartphone up and down, and it's collecting that data. So on the smartphone, what you'll see is something like this. All right. So once the data is uploaded, you will find it in the graph here below. So you can clearly see that this is the z-axis data. The accelerometer is constantly showing some a sinusoidal variation as I was like moving my phone in that fashion. That's why you will not see much variation in the other two axes, like the accelerometer x or the accelerometer y, because I was just moving along the z direction. All right, so we have collected this data set. Now, it's not just enough to collect a training data set. You also need to validate your model by actually testing that. So for that, we need to create a test data set also. So for that, what we can do is we can write something. We can create a test gesture label, and then we can again start sampling here. So in your test you like to cover all sorts of cases so that your model can easily recognize whether this is an up down motion or not. So again I'll repeat whatever I did just now. I'll repeat the up down motion. You can see that it's still recording data. All right, we have done uploading. Here you can see the data that has been sampled. Now what you can do is you can send this you can move this data to a test set, because by default everything will be taken into the training data set. So you can, yeah, you can move it to the test data set. So another thing we are going to do is we are going to create a gesture for making a circle. So I'll just create a clockwise circle, and let's see if our model is able to recognize that. So I'll just start sampling. All right, I guess we have collected enough data. It's uploading. Let's upload. Oops, did we name? Oh, so here we have forgotten to name the label as a circle or something like that. So there's no issue as such. You can directly edit the label and name it, since it was a circle about the x-axis, so let's name it x circle. All right. I guess we'll have to refresh to see the changes. No, not an issue. We can again collect another sample. All right. So we have X circle with us. So we can start sampling. All right. Done sampling. So just notice the change in the graph. Here you can see that not just the acceleration in the z direction, but also along the accelerometers is changing. Why this is happening can be explained, like it involves a bit of physics, but here let's not discuss that here. Our focus over here is whether our model is be able to recognize whatever gestures we are giving it or not. So let's not focus on that. All right, so we also need to create a test data set for this. So let's name it x circle test. You can start sampling. All right, we have started sampling our data. Yeah, we are good to go now. So we can move this to the test data set. Yes. And and we can just ignore this up down data set since we have already added that. All right, so now we are ready to train our model. Let's do that. So for that you'll have to move to the impulse design tab, and over here the main things that you need to tweak are firstly the window size. Now what do I mean by the window size? Probably I'll explain this a bit later. So what you've actually done is that you have taken a large number of samples from your accelerometer, like sampled at a certain frequency. For my case, it was 62.5 hertz. So at 62.5 hertz, you've taken thousands of samples, in the duration of 10 seconds. So you've taken around what, say 625 samples, yeah. So what this window size does is that it takes a window and keeps breaking the entire data set into parts. Like over here the window size is 2000 milliseconds, which means my entire data set spans 10 seconds. So I'll not try to recognize the gesture in the entire block at once. I'll take a small portion, which is called the window, and I'll keep shifting this window to continuously see whether getting a particular gesture or not. Because why I'm doing this is because, like, if suppose I want to recognize a circular motion, it's not necessary that my movement will start from from 90 degrees, or it will start from 270 degrees. It's not, we never know. It will start from anywhere. So I'll have to keep checking at every point whether I'm getting that kind of motion or not. This will become more clearer in the next part, so I'll not discuss that more over here. What we need to add over here is a processing block. Like, how do we want to process the signal that we have received? Obviously, for beginners, understanding this is a bit tough. So, what I recommend is just use the recommended filters that Edge Impulse suggests, and believe me, these filters work really great. So, first we'll add the spectral analysis block, which does nothing but converts the time series data into frequency data and also performs some digital signal filtering. The next block that we'll add is a neural network that will try to classify the different types of gestures that we have just in. So you can see over here that we have two output features called up, down, and X circle. These are the two types of motions or gestures that we are trying to recognize. So we can just save this impulse. So what we are doing is we are just saving the kind of like processing techniques that we want to use for this particular data set. Once that is done, we can move to the spectral features tab. All right. So here is where the concept of windowing coming comes in. You have these many samples and you keep sliding your window across these samples. So at any point, uh, so you'll see that you'll get a different graph at every point on when I shift this window. So I want to recognize a particular type of motion, say this kind of motion. So you can see the different kinds of graphs that are coming up. So if you've studied machines like electrical machines, you know something about induction motors or something like that, then you will find this graph very familiar. I know this is a bad analogy, but that's the closest I can think about right now. So yeah, you can see also see the other kinds of other data set that I captured. That is the up down motion data set. So clearly you can see that the variation along the z axis is much more than the other two axes. Alright, so once you confirm that whatever whatever inference you have drawn is perfect, you can just go ahead and click on save parameters. Once you've done that, the next thing you have to do is use the training set to generate the model. For that, we'll just click on generate features. It will do some processing in the background and the result will be shown. Alright, so what you see over here are two point clouds. What these point clouds represent are the uh, different values in the like these are normalized values along the x, y, and z axis that will be used for classification. You can see that the up down motion data set is distinct from the x circle or the circular motion data set. So this shows that we have actually trained our model very well, because there's no overlap of data between these two point clouds. So an up down motion wouldn't be mistakenly recognized as a circular motion. Another thing you can see is the processing time. So you can see that the processing time is just 7 milliseconds, which is actually really cool. So another thing is the peak RAM usage. It's just 5 kilobytes of RAM. Like this can be much more for more memory constrained devices like an Arduino Nano 33, but it depends on the device. But here we are using a smartphone. It's a pretty advanced device, so uh, in terms of memory constraints, it's much more superior than other embedded devices. The processing is much faster. All right. So once we have generated the features, we can go to the neural network settings. I would suggest just go ahead with whatever settings Edge Impulse like gives to you, because this would require more knowledge of neural networks, which I believe most viewers won't have. So one thing you can do is either you can look into some videos on how neural networks actually work, how different layers are configured, or you can just simply uh, rely on the algorithms that Edge Impulse uses and just start training your data set. So I'll just walk you through what all we have done. We have connected our smartphone to our to Edge Impulse. We have collected the accelerometer data. We have designed processing blocks to process that signal, and then we have also generated the features that we want to extract from our model, which gave us the point clouds, different point clouds that represent the two kinds of gestures that we want to segregate. So after that, we created this neural network classifier, which actually classifies those two point clouds as distinct graphs. So here you can see that we get an accuracy of 85.4%. So which means that there is still some overlap between these two models, because this also happens because the method of collecting data is not very accurate. Like I was not moving my smartphone exactly uh, along the z-axis, and some component of circular motion also came in, because I I didn't like I don't have a proper test bench for this. So an accuracy of 85% for an embedded application is fine since the application is not critical, but in the general case, you should prefer an accuracy of over 90% at least. So, just for the sake of demonstration, we'll move ahead with this. So, we don't want to retrain our model over here. Actually, we can do that. Let's try to do. All right. So what this will do is that based on the outcomes uh, that Edge Impulse calculated, like the accuracy of 85.4%, it makes some changes to the model internally and then creates another classifier with a much better accuracy. So like now we want to collect some more data so that we can test whatever model we have created works plausibly or not. So for that I had already collected some test data. So now I'll just use that test data that I've collected. First I'll do the test for the up and down gesture recognition. So let's see whether it's able to recognize the up down motion or not. Alright, so you can see that it recognizes the up down motion like with an accuracy of around 90%, more than 90%, which is really good. Which means that out of if the total number of if the total number of data like the number of times you do an up and down motion is 92 plus 4 plus 5, then which is 101, which you can approximate it to 100. So 92% of the times it will be recognized as an up down motion, and only 8% of the times it will be only 4% of the times it will be recognized as a circle, and the rest of the 5 times are uncertain. Why these happen are very deeply linked to how neural networks actually work, so I'm not going into that. We don't need that over here also. So once we have done with that, we can move ahead to model testing. Actually, we have already done that, so we don't need to do any model testing. After this, I suppose you'll want to deploy it to your like. All right, you have created a model. You know that it works fine, but you also want to deploy it on an embedded device. So how do you do that? For that, you have this deployment tab over here that helps you create a library, like a machine learning library that instantiates your model. Like you can directly import that C++ library into whatever uh, like whatever code you want to run. Like if you want to run the code in Arduino, whether you want to use an STM32 based model or you want to run it on NVIDIA Jetson Nano, you can. It's not vendor specific or platform specific. You can directly use the library you have generated on any machine. And you can generate libraries for all sorts of platforms. Also, there's another option to directly create binaries. Like, uh, suppose you select the Arduino 33BLE sense over here. You don't need to write any other code to make this model to work. You can directly power up your Nano 33 BLE sense and just start machine learning on the go without writing any code. Yeah, you heard that right. So there are various different platforms that are available for doing this. You just need to click on build and connect your hardware. Alright guys, so that's it for this time. I hope I was able to put across the concept of edge impulse very clearly. I hope you understand the concept of how we went about doing the data collection, then the training, then the testing, and finally deploying the model on an actual embedded development platform. Do like, share, and subscribe this video, and do stay tuned for other cool videos like those on other embedded platforms like Arduino and ESP32. For now, goodbye, take care, and stay creative.